Hello my dear students, once again welcome to your online class. Today we will be continuing with the chapter matrix, and today we will learn how to find the adjoint of a given matrix. Okay, so in the previous chapter, in the chapter of determinant, we have already learned how to get the cofactor of each of the element. So in a matrix, what we do, so if I have a matrix A whose element is A, B, C, D, E, F, G, H and I. So to get the adjoint of this matrix, what will I do? I will find the cofactor of each of these element. Okay, so I will find the cofactor of A and write here as A11. Cofactor of B, I will write as A12, A13, A21, A22, A23, A31, A32 and A33. Okay, so this is the matrix that I have obtained by writing the cofactor of each of these elements. Now if I find each transpose, then that is known as the adjoint of A. Okay, so adjoint of A will be given by the transpose of this one. That means I'll change the row and interchange the row and the column. So like I'll write A11, A12, A13, then I'll write A21, A22, A32, A23 and finally A31, A32 and A33. Okay, so this is how we obtain the adjoint of a given matrix. So what we need to do, we need to find the cofactor of each of the elements of the determinant, not determinant of the matrix, and then we need to transpose it. On transposing it, we get the determinant, which is a matrix, which is known as the adjoint of a given matrix. So adjoint of the given matrix is very important in the sense because the adjoint of matrix is used in getting the inverse of a matrix. Okay, so now what is the inverse of a matrix? Suppose if I have a matrix A, if you are asked to find the inverse of A, then you have to find the matrix B such that if I multiply A into its inverse, I get the identity matrix I. Okay, so write it as A into A inverse is equals to I. Okay, so there is a specific way to find the inverse of a given matrix whose order is of 3, and that is included in your syllabus. So let us try to find the adjoint of the matrix and as well as the inverse of a matrix in a simple question from your book. So if we have any matrix A, okay, so if we are asked to find the A inverse, then we simply use the expression to get the A inverse is simply is equals to 1 divided by the determinant of A into adjoint of the given matrix A. Okay, so this formula is utilized in getting the inverse of a given matrix. So it is 1 divided by the determinant of A and adjoint of A. And also remember that the inverse of the matrix exists only if the matrix is a non-singular. Non-singular means suppose if I have a matrix A and if you find the determinant of A, okay, and if the value of its determinant is not equal to 0, then it is known as a non-singular matrix, and if the value of the determinant of the given matrix is equal to 0, it is known as a singular matrix. Okay, so if the matrix is singular, its determinant its inverse does not exist, because in the formula if I put the value of the determinant there equals to 0, then it becomes infinity or undefined. So that's why our matrix exists only if the given matrix, the determinant of a given matrix is a non-singular. That means the value of the determinant is not equals to 0. So we'll try to do one sum which will give you the idea of both the adjoint and the inverse of a given matrix. So let's begin. So the value of this determinant, I will expand it, it will be 1 into, so 2 4 is 8, 3 2 is 6, so minus 6, then again plus 1, so this and this goes away, so 0 plus 3 3 is 9, and then finally plus 2, and then these elements away, 0 into 2 is 0, 2 3 is minus 6. Okay, so this will give me 8 minus 6 is 2 plus this gives me 9, and that will give me 2 6 is minus 12. So this gives me 11 minus 12, which is equals to minus 1. So therefore the determinant of the given matrix is not equals to 0. So therefore its value exists, which is equals to minus 1. Now the second thing we'll find is, we'll have to find the cofactor of each of these elements, which we have already learned in class, the previous class, that is in the chapter of determinant. So I'll begin with the first one. So I need to find the cofactor of the first element 1. Okay, that is A11. So it will be simply, I will eliminate the row and the column, and then I'll find the value of the determinant obtained by eliminating the row and the column in which the given element is contained. So here it is 4 to the 8 and 3 to the is 6 plus 6. So that will give, so not plus 6, sorry, it is minus 6. So that will give me 2. In the same way, I'll find for the second element cofactor of minus 1, that is A12. So which will be equals to, so here I have written down the cofactor of each of the elements of 1, minus 1, 2, 0, 2, 3, minus 3, 3, 2 and minus 4. So of this cofactor, I will form the matrix X. So let there be a not matrix, let the matrix B be formed by the cofactor of each of these elements. So I will write this one as 2, minus 9, then 0, 2 minus, no, not 0, sorry, it's minus 6, 0, then minus 2, then I have minus 1, then I have minus 1, then I have 3, and then the 2. Okay. So now to get the adjoint, what will I do? So I will simply write the adjoint of A will be equals to the transpose of this matrix. So what will be the transpose of this matrix? The transpose of this matrix will simply be 2, minus 9, minus 6, and then 0, minus 2, and minus 1, and then minus 1, 3 and 2. Okay, so now the inverse of the matrix A inverse will be equals to 1 divided by the determinant of A into the adjoint of the given matrix A. Okay, so I already have found out the value of the determinant of A. So simply I will replace all the values here. So with this will be equals to 1 divided by minus 1. Yeah, I see the value of the determinant is minus 1 into the adjoint of A. I'll write this matrix 2, 0, minus 1, minus 9, minus 2, 3, minus 6, minus 1, and then the 2. Okay, so finally what will I do? I'll simply multiply each of the elements of the given matrix with minus sign. On doing so, I'll get, so therefore the A inverse, I'll write it here. Since there is no place, I'll write here. So A inverse will be equal to, I'll simply change the sign. So this will be equals to minus 2, 0, 1, 9, 2, minus 3, 6, 1 and minus 2. Okay, so this is how we find the adjoint and as well as the inverse of the given matrix. So in examination you may get question like find the adjoint of the given matrix, or directly you may find the inverse of the given matrix. Okay, so this is the procedure to find the inverse of a matrix. So you may do rest of the remaining exercise question from your book. So in the next class we will be beginning a new chapter. Thank you.